Hello everyone, welcome to another exploratory data analysis and machine learning tutorial by Slidescope. In this part, we will learn how to perform EDA and ML on spam-based dataset. Spam-based dataset can be downloaded from UCI machine learning repository, and as the name suggests, this is for classifying email as spam or non-spam. The spam-based dataset from UCI machine learning repository is a well-known dataset used in machine learning and data science, particularly for email classification tasks. It commonly uses, it is commonly used to classify emails as spam or not spam. The purpose of this dataset is to distinguish between spam and non-spam emails, and number of instances are 4601 emails. Number of features used are 57 continuous variable and one binary class label, which is spam or non-spam. The frequency of specific words and characters, example free, money, business, capitalization patterns, example percentage of capital letters in the email, and other structural characteristics. Some common uses are logistic regression, decision trees, support vector machines, naive Bayes classifier, neural network. We will see that classification in this chapter. Here we have created all the steps. The first step is to load the dataset. So download the dataset from the UCI repository, and from here when you will download the dataset, you will get three files in a zip: spam-based.data, spam-based.names. So let's see the steps to load the data. First, import pandas SPD. We are using Google Colab, Jupyter Notebook, the cloud hosted Jupyter Notebook on Google Colab, connected to Python 3 Google Compute Engine backend. And now in our file manager, we will upload that file that I just you know displayed you. So by clicking on upload here, we will upload the file and make sure that the file is loaded properly. After loading the file, we will use all the column names. The column names is equal to feature for I in range 1 to 58 plus spam. And for spam based data, we will use pd.read spam based file here, and we will simply copy the path and put it here. Let's run this. When you will run this, you will have your spam based data, and here you can see different features. All the features, all the 58 features that we have, 57 sorry, and meaning of all these features is provided here. So for example, word frequency make, word frequency address, word frequency all, frequency 3D, etc. Every meaning of every feature is given here. Now we will write df.head to see the top 5 rows, and before that what I will do is, first of all, I will save this to 2 underscore CSV. So spam base.csv. So when I will provide it to you, you can simply use pt.read underscore csv to read this, and I will say df is equal to our data frame is equal to spam based data, and then I will simply write df.head. This will show us top 5 rows of the data set. Next is, we will analyze the target class spam, and here we will use, so we will analyze the target class spam to see the proportion of spam and non-spam emails. So we will use print spam based data dot value count. So you can see the proportion of spam is 0.60%, and almost 40% is 1. So spam 0, not spam 60%, and 1 40%. So in the samples given, we have 60% non-spam values and 40% spam values. Here, let's see some variables. So in the official website, word frequency your, credit, you, email, business, free, addresses, report, people. So all the features here are showing frequency of certain words like all, 3D, our, over, remove, internet, etc. Right? So the features can broadly be categorized into following types like word frequency features. These are features 1 to 48. These features represent the percentage occurrence of specific words in email text, and each value is calculated as word frequency is equal to number of times the word appears in the email divided by total number of words in the email into 100. Example words make, address, free, money, business that you just saw. High frequencies of words like free or money are often indicative of spam. Then from features 49 to 54, these are character frequency features. These features represent the percentage of specific characters in the email text calculated similarly to word frequencies. Example semicolon, parenthesis open, square bracket, exclamation, dollar, hashtag. For example, spammer may use a high frequency of exclamation or dollar to emphasize promotion of financial terms. Then we also have capital return length features, which are from 55 to 57. These features measure pattern related to use of uppercase capitalized letters. So average length of capital letters, average number of consecutive uppercase letters in a sequence, which is feature 55. Feature 56 is longest capital run letter. Feature 57 is total capital letter occurrences. And then we have the class level, which is target value. 1, the email is spam, and 0, the email is not spam. So that's why this particular data set, the entire data set here, is example of a classification can be used for classification of spam versus non-spam emails is a supervised data set because you have some samples. Now, you also receive an email. In your email, using NLTK or other libraries, you can check occurrences of these type of words, and based on your machine learning model, it will be able to predict whether the email received is a spam or not spam. That's why there are many there are many good emails also that are sometimes sent to your junk folder or spam folder by Gmail or Yahoo Mail. So that still happens. And here are different feature names: word frequency, make, percentage of occurrences, make, higher in promotional emails, make money fast, right? Word frequency free, percentage of word free, common in spam emails offering free items. Now, to examine the distribution of features, we will use df.describe, right? Obviously, here feature 1, feature 2 are given. You have to go back and see what is feature 1, what is its standard deviation, minimum percentage, maximum percentage. So that is something that you will see. For example, word frequency make feature 1, which is its mean is 0.10, like in uh, on an average 10% of times it is used. So on the basis of this, you will be able to understand what's happening in describe here. This is something where you have this type of data set are something where you have to refer to the description several times, and I will provide the complete description URL to you as well. Next, we will see distribution of features for exploratory data analysis. So we will import the matplotlib.pyplot as PLT and import seaborn as SNS. These two libraries have been taught several times in our previous videos in the playlist. So in this video, we are just importing these libraries to plot graphs. We are using the histogram plot. Histogram plot is used to plot, see the distribution of data set. So let's say we have taken feature 1. and we have written KDE is equal to true. So this simple plot is telling us that most of the values the in feature 1 are between 0 to, let's say, zero point 0.4 range. So maximum value is 4.5% the density of this keyword. So this particular word make appears on an average it appears 0.10. Its density is 0.10. So out of 100 words, its density is 0.10. So you can see there are certain cases in which this particular word has been used 2% or 3% of times out of 100 words. And the distribution is showing us that in almost 4,000 emails, this is used less than 0.4% out of 100, right? So that's what you can see here. Next, we will do correlation analysis. Compute the correlation matrix to find relationship between features and target variable. So here you can see the color map that we are using is school warm, and you can see first one is feature 1, and then here you have spam, right? So this last variable is our target variable, and here you can see the different ranges. This particular thing shows correlationship between feature 1 and spam, being spam, classified as spam. So here you can see these values are in lighter shade. For example, feature 21, right? Feature 26, 23 or 24, right? So whatever feature values you can see in light color here are the features which will help us in recognizing the email as a spam or non-spam. So on the basis of these color palettes, you will be able to find that. Next, we will perform target versus feature analysis. So compare the distribution of features for spam versus non-spam emails. So here you can see in 0, we are barely able to see the box plot. We are using sns.box plot. Here in X, we are putting spam, and on, so spam will have two classes, 0 and 1. And on Y, we are using feature 1, and data is equal to spam based data. Obviously, in data you have to provide the name. You can see we have a lot of outliers here, and this is how the data is distributed. You can also change features like, let's say, feature 56 or feature 23. So this way you will be able to see effect of feature 23 on spam 1, distribution of the variables, different type of variables in feature 23, different type of values in feature 23 in being categorized as a spam. And box plot is something that we have discussed multiple times in our previous chapters also. Next, we will do pre-processing. First, we will do feature scaling, that is normalize or standardize features using standard scaler and minimum scaler, because all the features have different type of scales. So for example, some of them are, you can see, for some maximum value is 42, for some maximum value is 4.5, etc. So we have different type of scales here. Like for feature 55, this value is 1102. So when you have different type of scales in your data set, so you will use the standard scaler and min-max scaler. You can use any one of them. So here we are using scalar.preprocessing standard scaler. So we are creating an object of a standard scalar class, and we are using x variable here. So x is the input variable, that is all features except the target value, and y will be our target value. So we are using spam based data.ilog from hashtag. This is a way to simply select all the features here except the target -1. So starting from 0 to -1. And here in spam based data, we are just selecting spam, and we will use our features input called x scaled. So where we will use scalar dot fit transform x. When you will do this, X scaled will be created, and let's write S scale dot head. So this way we will have our input array because it's an array. So that's why we cannot use head here. This is an array. We can convert this array. Obviously, this array will be used to train our model. Now next we will use train test split to split the entire data set into training and testing. So we will use X train, X test, Y train and Y test. So we are using sklearn.model selection from this module. We are importing train test split, which we have used in many previous examples. And we are keeping the test size as 30% and keeping random state as 42. So basically here we will not use X, we will use X scaled, because in X scaled you can see every value, every feature value is now scaled using the standard scaler. And here you will write X train, X test, Y train and Y test, right? So when you will use X train, you will see number of values inside your training part, and when you will use Y train, so you will see, you know, your output, which is a series. Next, there can be an optional step. You can handle imbalanced data. If the data set is imbalanced, you can use techniques like oversampling, smart or undersampling. So this is something that we will see in other examples. And next, we will build machine learning models. We will train models. Start with simple models like logistic regression and decision tree, and then we can try more advanced models like SVM or random forest or gradient boosting, etc. So in this chapter we will use random forest classifier. So from sklearn.ensemble we will use random forest classifier. Random forest classifier is just like decision tree where you will apply multiple decision trees. So its theory and its basic description how it works has been taught in previous videos also in the same playlist. So you can watch that. Basically, we will use random forest classifier class to create our model. You can use any random state to select values, and then model will be fit. In model we will fit the training data. So X train and Y train, the training set will be fit, and this way model will learn about, the inputs and output and their relationship. Next thing is you can evaluate model. You can use metrics like accuracy, precision, recall, F1 score and ROC, which we explained in the previous video also. I will leave a link to that video in this description also, so that you can go and watch accuracy, precision, recall, meaning of these. Accuracy and precision you already know. These are used to check the overall score of model, overall accuracy of model. To do that, you just have to use from sklearn.metrics import classification report and confusion metric and ROC AUC score. Then in your Y predicted, you will create Y predicted using model.predict. So model.predict method will take the testing data, and on the basis of that it will predict some values for all testing. Let's say in X text there are 1387 rows and 57 columns, right? So on the basis of these many rows, it will create these many samples, okay? And then you will use classification report. In classification report, you will use Y test and Y predicted. And for printing the ROC AUC, we will use ROC AUC score. So here we will use Y test and model.predict probability X test, and here we will select from 0 to 1. So this way you will be able to predict these values. So ROC AUC is 0.98 and you can see precision 0.95. So these are two different classes for non-spam and for spam. So you can see model is able to predict it very accurately, right? 95% it is able to predict non-spam values, and 97% of the times it is able to predict the spam values correctly. You can also do the hyperparameter testing. So you can use grid search CV or randomized search CV to optimize your hyperparameters. What are hyperparameters? What is hyperparameter tuning has been discussed previously also. So when obviously you should have some idea about that, then you will be better able to understand this step, and that's why a video link will be shared. So here we are using grid search. So from sklearn model selection, we are importing grid search and we are creating a parameter grid. So for random forest classifier, we can supply n number of estimators. This is just like how many trees are you applying to get the majority voting. So in n number of estimators, we are adding 50, 100 and 200. Maximum depth is none, 10 and 20. And here we are doing grid search on random forest classifier, where we are first providing our classifier, then the parameter grid, and we are using grid search CV, we are using CV is equal to 5. So when you will do this, it will do grid search and fit X train from a Y train. This will take some time because it will do it 3 times. So here you can see in grid search, you have grid search CV is equal to estimator random forest classifier, parameter grid, etc. Everything is there. So best estimator for random forest classifier number of estimator 200, and here you can see, and here we are going to perform the final step, that is step 6, feature importance. Identify the most influential features using model specific attributes like feature importance for tree based models. So we will use importances variable here to store the feature importances, and use sns.bar plot. In bar plot we will, in X we will use importances, and on Y we will write the column names, that is the feature names. So here you can see, for example, let me do one more thing. So I will just use plt.figure to create the fixed size, and this way we can open the image in a new tab. Here you can see all the important features like figure 52. Feature 52 is important. So from here you can see what 52 means. So features from 49 to 54 are these type of features, right? So that way you will be able to understand. So in a variable where you have dollar sign or exclamation, those features are kind of representing those emails where which can be a potential spam email. So from here you can see different important features like feature 7, feature 52, etc. So let's say from top, what is the seventh? 1, 2, 3, 4, 5, 6. Remove. Now after creating your model, seeing most influential features for predicting spam, not in spam, we can also save our model. So we can use spam classifier.pkl. So using joblib, we will use joblib.dump. So to save our model that can be used later for further analysis. Now this way you will have your spam classifier model, which you can use for further classification. Now, what are the next step? You can test the model on unseen data to validate it for real world performance. So we have used NLP tutorials also. In NLP tutorials, let's say you have an email, let's say there are 200 words. So you can find out frequency of words there, right? So take 20 or 30 different emails, for example, and break those emails into these 57 features. That is something that we will discuss in the second part, how to use this model to predict real emails. So we will use some of our emails. Obviously, we'll use a mix of emails. Some of them will be spam. We know is they will be spam. Some of them will not be spam. So using word tokenized in NLP, we will first convert our data set into this type of data where we have the word frequency like this, and then we will try to predict how many of them our model is able to predict correctly as spam and not spam. So for that, you before that first proceed with this. Obviously, many terms used in this particular chapter will be are those terms which will be known to someone who has performed the machine learning exercise many times, who has done or applied machine learning on multiple data sets. And even if you are not able to understand anything, you can you can ask that in the comment section. So thanks for watching this video. Have a nice day. Please subscribe to our channel if you want to see notification about more such tutorials and about the next chapter also.